I'm Carl Anthony with AutoSens TV here at AutoSens Brussels 2019 from the Auto World Museum. We're speaking today with Werner Brockherde, head of the Optical Sensor Business Unit for Fraunhofer IMS. And Werner, so good to have you today.
Yeah, thank you very much, Carl. Yes, may I start with a short introduction of our institute, what we are doing, maybe?
I think that's a great way. I was just going to ask that question. Let's do that.
Okay, so we are one of 72 institutes, I believe it's 72, and we are located in the west of Germany, in Duisburg, and our business is based on CMOS technology. So we are working from the beginning on CMOS technologies since 1985 with development of special CMOS processes, circuit design, chip prototyping, and even pilot production of silicon chips. So that's our main business, and for me, I'm head of the Optical Sensors business unit. We are integrating optical sensors into the CMOS process. So that's our main activity. And with that, we did a lot of new devices in CMOS process. For example, SPAD devices, which we are also showing here. We also have, besides CMOS technology, we have microsystems technology, also a huge clean room which we use, where we do back-end processing of chips, for example, for this LiDAR technology, but also for the far infrared technology, where we do the chip scale package, vacuum package, microbolometer technology for thermal imaging. So there are a lot of different applications which we serve with our technology.
So, Werner, we were talking off camera about the activities that you have specifically for LiDAR. Tell us a little bit about that.
Okay, wonderful. Yes, we are in the LiDAR range. You can imagine active in the detectors. So we have developed some special detectors for LiDAR based on SPAD technology, single photon avalanche diode, which we think is the best way to detect very few photons which you need for LiDAR systems. So if you want to get large distances, you need very sensitive devices, and the SPAD is it's the best suited candidate.
Sure.
And so the integration of SPAD into the CMOS technology allows for different new applications. So we can integrate SPAD arrays together with the electronics on the same chip, and with this co-integration of both detector and readout and processing circuitry, we have potentially very low-cost devices at the end. So in LiDAR, you have the problem that the LiDAR is still very expensive, and we are on this way to make it cheaper. So our approach is pure solid state without any moving elements, maybe also without micromirrors. You can use flash, but you can also use the SPAD arrays with micromirrors. That's also possible. Yes, that's what we are doing. And today, on this fair, we first introduce a new way of integration. The new way is to have two layers. As I mentioned, you have a lot of electronics together with your SPAD arrays. So we integrate the SPAD array on top of the electronics now. So we have two wafers. We do wafer bonding, which is a very sophisticated technology. Wafer bonding face-to-face, two wafers. The lower wafer, the readout IC with all the electronics, and the upper wafer is the detector. So the advantage is that you can optimize both layers. You can optimize the circuit layer for minimum feature size, for low power, and so on. And you can optimize the detector array for the right wavelengths. So the CMOS SPADs are not very sensitive in the near infrared, but with a separate layer on top of the readout, you can optimize it for near infrared, for example. And with that, you can have much more pixels on the same area as you have when you integrate it in one layer. So about 10 to 50 times more pixel on the same layer. So actually we have a very small array in fabrication. It's only 64 by 48 pixels. That will come out of the fab end of this month. And we are very excited to get the results. But this is scalable, so you can scale it up to VGA resolution or something like that.
So Werner, tell us a little bit about what you have on display here at AutoSens for the attendees to see.
Yeah, so what we can see here, unfortunately, is not this sensor I just mentioned. So we have a time-of-flight sensor or LiDAR sensor based on two linear arrays. So it's only two linear arrays, 2 times 192 pixels. And each of these pixels has a time-to-digital converter, so we can, in one shot, measure the distance for all these almost 400 pixels. So that's what we can show here. This is very sensitive, as I mentioned, and yes, we are mainly working on the side of the detector. But of course, we need, for this demonstration, we need also a camera. We need illumination, we need optics, and so on. So we work also on this area. Especially, we are working on background light suppression, which is very important, especially for the automotive applications. We have developed a lot of new algorithms, filed a lot of patents in this field also. And this is one activity. Another activity is due to the fact that we talk to almost every tier 1 and OEM. We have a lot of knowledge about this area, and we know that there is a great confusion about the right systems. And what we are trying to do is we try to benchmark the technologies. And as a research institute, I think we are the right organization to do benchmarking of this technology. So there's a great request from the industry because they are all very confused about this.
Werner, we want to thank you for your time. Do you have any final thoughts to add before we conclude our interview?
Yes, we believe that in future LiDAR systems in cars, there will be not only one LiDAR. So at the end, might be there is a far-looking scanning LiDAR, but there will also be some flash LiDARs seeing around the car, 360-degree around the car, which will look not 100 or 200 meters, but 30 to 50 meters, and that's enough. And because you have some of these devices, they have to be very cheap. And we believe in solid-state flash LiDAR systems based on our technology, of course.
Werner, thank you for your time. From all of us at AutoSens TV, we want to wish you good luck going forward and safe travels home.
Yeah, thank you very much, Carl.
Speaking today with Werner Brockherde from Fraunhofer IMS at AutoSens Brussels 2019. For more AutoSens, like, subscribe, and share.